Okay, this video is by request of one of my listeners, follower. Actually, I don't know follower or not. So it's about tangent line problem. But before I solve that problem, I decided for my followers, I decided to give some introduction so you would know what it is, what I'm talking about. And therefore, before I solve that problem, I will solve a couple of easier problems that will give you idea about how to solve the problem that was requested. It's not difficult, but you just need to understand terminology and just figure out what tangent line is and what tangent line give us, what information we can gather from tangent line. First of all, tangent line is a straight line that touches a function at only one point. Here we go. This is tangent line. Okay. The tangent line represents the instantaneous rate of change, which is derivative, right? Remember in my previous video, I said that the limit gives us average, the speed, average rate of change, but derivative gives us instantaneous rate of change. So tangent line is a instantaneous rate of change, shows geometrically or on the graph, right? And the slope of the tangent line at this point on the function is equal the derivative of the function at the same point. Okay, so let me show you a couple of examples of tangent line. So if I have such curve, oops, and I have such a line, now this is tangent line, this point that it touches. But this is crossing. This point is not a tangent line. Okay? When it's crossing, it practically crossing. It's not touching. Touching, it's from outside, but here is just crossing the graph. Also, let's say I'll give you such example. Let's say we have this type of curve and we have graph that, we have tangent line that goes like this. And then, hold on. You have, let's say, such type of curve and this is gonna be your tangent line as long as it touches one point. Now, let's assume we have such curve, okay, and the line goes like that. This is what we call secant. So, what is secant line? First of all, the use of word secant comes from the Latin secere, which means to cut. And it is not a reference to the trigonometric functions of the same name. So don't get confused. This is not the same secant that we use in trig functions, in trigonometry, okay? So let's assume we have the point here. This is starting point. And that is point C and f of C. All right. So it's moving to this point, ending point, which is going to be C plus delta and comma f of c plus delta x. Okay, so it's let's say it's some object moved from the beginning to a starting point to that point. So what do we have? This displacement. This is going to be my delta x because change of x. This is going to be my delta y, change of y. Okay, and delta y, delta x is going to be equal c plus delta x minus c. It's going to be equal delta x. So the same way, delta y, it's going to be f of c plus delta x minus f of c. It's going to be equal delta y because it's going to be left only f of delta x, which is going to be delta y. All right. So what is secant line and why do we use here? I reminded you about secant line. Move a little bit. Okay, much better. So the secant line is a straight line joining 2 points on the function, here and here. So secant line is the average rate of change. Secant line is average rate of change and it is also slope. So tangent line is an instantaneous rate of change. Secant line is the average rate of change or slope. Oops, what is this? All right, so practically this is our secant line. And this is our secant line is average rate of change and it is also slope. So tangent line is an instantaneous rate of change. Secant line is the average rate of change or slope. Oops, what is this? All right, so practically this is our secant line. And this is our tangent line. Well, it just happened it is parallel. It doesn't necessarily, oh, okay. Secant line, tangent line. Okay, I need to get this. And this is going to be our tangent line. Okay? So, the average rate of change of the function between 2 points and the slope between these 2 points are the same thing, just so you know. So, and tangent line, as I mentioned, it's a straight line that touches a function only at 1 point. So, tangent line, I am repeating, but it doesn't hurt. Tangent, let me write down. Tangent line equal instantaneous instantaneous rate of change. Just so you see the difference, average rate of change, instant rate of change, okay? And also it's equal, derivative, right? Okay, I already spoke, right? At the instantaneous rate of change, it's a derivative, and limit is a average, right? So how we can get, if let's say, if I take, let's say, secant line, why I keep taking this curve, because it's very it's a bright example and it shows very well. Let's say here is my secant. So if I take the delta, this delta, you see this delta, okay, let me show here. This is my delta x, right? If I take delta x, that approaches to 0, which means the line is going to go like this, cross here, and then cross here, and then cross here, and then here, until it will become tangent line. Now, like that. Okay, it will become tangent line where the limit that is equal 0, looks like messy here, is equal 0. It will become, when a limit of secant line, it's a tangent line. Okay, that's where delta x become 0. At the point where delta x becomes 0, we are getting tangent line. Okay, so let's start, since I gave you some idea, then let's start solving some basic problems. So we need to find the slope of the graph of a linear function. So we have here linear function. This one, and I have such graph. Okay, so I'm not going to follow proportionality of the x and y. I'm just going to throw numbers I am interested. Let's say this is my 2 and 1 point. Okay, and I have the graph. This graph is y is equal 2x minus 3. So we need to find the slope of this graph at the point c is equal 2. Okay, so we are going to apply definition of slope. So if this is my 2, this ending point, let's say, is gonna be 2 plus delta x, right? Let's say this ending point, it's going to be 2 plus delta x, which means we are going to have limit x delta x approaches to 0. Remember, we are going to get from here, slowly get to here. So it's going to be equal f of 2 plus delta x. This is going to be your 2 plus delta x. This is And this one is f of 2 plus delta x, right? So f of 2 plus delta x minus f of 2, right? Ending point, y2, okay. I'm using here for the definition of slope, y2 minus y1, x2 minus x1. So y2 is my ending point, right? The f of 2 plus delta x, and y1 is my starting point, f of 2, right? Taking difference and divided by difference between x's, which is going to be delta x. Now 2 plus delta x, this is the point. This point, not this distance. Distance is delta x. Okay, let me make it crystal clear so you would understand, not confuse you. This is delta x, and this point, x for this point is going to be 2 plus delta x. And the y, it's going to be f of 2 plus delta x. Okay? Let me move this higher. Rewrite this. Getting messy. F plus 2 plus delta x, this is our x, right? New x. And f of 2 plus delta x, it's going to be our y. Let's say y2, x2, right? This one, it's going to be x1, y1, okay? And here we go. Divided by, so delta x. X2 minus x1, it's a delta x. And we are getting limit delta x approaches to 0. So I'm getting twice 2 plus delta x minus 3. What am I doing? This f of 2 plus delta x, I am replacing with the 2x minus 3, right? So instead of x, I'm plugging this x, I'm plugging with 2 plus delta x. So it's going to be 2 times 2 plus delta x and minus 3. And minus 2 times 2 minus 3. Okay, y1. So y1 is going to be f of 2x, and minus 3. So what do I have here? This piece is my y2, right? Which is right here. So I'm plugging, instead of x, I'm plugging 2 plus delta x. The rest is the same. And this is my y1. Y1 is without delta x. It's just 2 times x, right? This is 2 times x and minus 3. That's what we have. And we divide by delta x. Okay, so from here, limit delta x approaches to 0. We are getting 4 plus 2 delta x. I'm doing algebra here. Minus 4 plus 3 divided by delta x. This is gone with this. And I am getting, what else? This is gone with this. And I am getting limit delta x approaches to 0 to delta x over delta x. So this delta x is gone with this delta x, and limit of 2, since it has nothing to do with delta x, so we are getting 2. So now let's arrange things in order. So the slope of f at the point of C and f of C is equal to, and at the point that is equal to and 1 is m is equal to. So this is the slope, m is equal to for f of C and f of C. Okay? Now, to remind you, our original function was f of x, where is it? Here it is. F of x equal to x minus 3. So it's in format mx plus b, right? And this is 2 is our slope, which we got right here. Okay, m is equal 2. So, practically the limit definition of the slope of f is agrees with the definition of the slope of a line. Okay, next example. Let me mark down, this is 1. Second one. We need to find tangent line to the graph of nonlinear function. Now we are going to deal with nonlinear function. Okay? And here is my graph. Wish me good luck. I need to draw parabola. And since I have x squared plus 1, I'm going to move this down by 1. So this is going to be, let's say, my x-axis, right? So this would be 1 here. Okay, so we are given the graph f of x that is equal x squared plus 1, and we need to find the slope of the tangent line at the point 0, 1, at this point, which is going to be this line, horizontal line, right? Okay, and at the point of negative 1 and 2. So this is looks like straight line. Okay, negative 1 and 2. So this is negative 1. Let me take this as a negative 1. And this is going to be negative 2. If I don't keep proportion, then forgive me. Use your imagination, please. Okay, negative 1 and 2. So the tangent line at this point is going to be this, right? Two tangent lines, so we are going to find the slopes for both tangent lines. Well, you can foresee already tangent line for 0, 1 coordinate, right? Okay, let's C and f of C represent an arbitrary point on the graph of f. Any point on the graph of f. Then the slope of tangent line it's gonna be limit delta x approaches to 0. It's going to be f of, again, c plus delta x minus f of c, right, divided by delta x, and this is going to be equal. So plugging instead of the f of x, I'm plugging c plus delta x, right? It's going to be limit x approaches to 0. Here I'm going to have c plus delta x squared plus 1. This is our f of x, right? Here it is. Okay. And minus c squared plus 1. So for the point of c, this is going to be, we're going to find our slope. So c plus delta x and then c. C squared plus 1. And we divide by delta x. So what did I do? Since it's at the final point, let's say this is how I'm going to do. Let me show you that point. This is my secant line. Ooh. So it has 2 points. One is here, right? And one is here. And that's where the tangent line is going in this point. This is our point C, practically. So it's we are doing our change. This is C plus delta x. This is C. And accordingly delta y. So this point, the function at this point is going to be c plus delta x squared plus 1. So instead of x squared, we are plugging c plus delta x squared. And this one is our original function. F of value of x is c, because it's at the point of c plus c squared plus 1. And divided by difference of this displacement. Okay? So this is going to be equal limit delta x approaches to 0, and we are getting c squared plus 2c delta x plus delta x squared plus 1 minus c squared minus 1, and we divide by delta x. Okay. Using some algebra here, and we are getting 2c delta x plus delta x squared. Okay, so, and this is equal limit x delta x approaches to 0, 2c plus delta x, and we are getting 2c. So I hope you understand why we are taking delta x approaches to 0, because we are moving slowly, the ending point moving slowly to the beginning point. So secant will become as a tangent line, right? Okay, so the slope at any point of, let me write down, slope at any point of C and f of C on the graph is m, that is equal to C. At the point of 0, 1, the slope is equal how much? So it C is going to be x is 0 there, right? So in the point 0, 1, m is going to be equal 0, 2 times 0, which is equal 0. Okay? And at the point -1 and 2, m is going to be equal twice times -1, right? Equal -2. Indeed, look at this tangent line. It's going down, decreasing, right? It's -2. Oops. Is equal -2. Okay. Now, the definition of something interesting I would like to read. The definition of tangent line to a curve does not cover the possibility of vertical tangent line. For the vertical tangent line, you can use the following definition. For the vertical line, vertical tangent line, it's going to be, so here let me write down example. Okay, at the point C and f of C. So this is vertical tangent line. Tangent line. Okay. It's going to be equal limit delta x approaches to 0, f of C plus delta x minus f of C over delta x is equal infinity. We know from even algebra that slope of vertical line is infinity, undefined, right? We don't use infinity in algebra. For algebra, undefined. For calculus, it's infinity. And since we are talking about vertical tangent line, then the slope of horizontal line, it's going to be 0. So this is why when the from NASA, the rocket is taking off, it's taking the vertically because the slope is going to be infinity. And when you are driving on the flat, a flat road, the slope is 0, right? Okay. Or we can have either way, positive infinity, negative infinity. That's why when they are digging for oil, let's say, or some other treasury of the nature, they drill down vertically, right? Not under the angle. And that explains because either also first one or this one, delta x approaches to 0, and we get f of C plus delta x minus f of C divided by delta x is going to be equal negative infinity. It depends on, if you're moving down from original point, you are going to reach negative infinity. If you are moving up, then it's going to get positive infinity. Okay. Next we will do graph with sharp turn. Number 3. Take a guess. What is going to be sharp turn? It's going to be absolute value, right? So this is what we have. Function f of x is equal absolute value x minus 2. It is continuous at x, at point of x is equal to. Let me draw the graph. And since we have absolute value and x minus 2, if we take this is 2, then the graph is going to go like this. And symmetrically, now I don't know how much, oh, horrible. Well, not bad. Okay, so this is x minus 2, absolute value x minus 2 graph. Okay, and look, here m is going to be positive, here is m going to be negative, right? Let's see how much we get. All right, so let's find the slope. So here we are going to get one-sided limit because one side is going to be positive, one side is going to be negative. Without even solving anything, we can see, because it's from algebra, we see that the graph is decreasing, slope is negative, the graph is increasing, slope is positive. So let's show it in the form of one-sided limit. Okay. So this is our 2. And why we are taking these two sides, positive and negative? Because it's absolute value. Absolute value, it's one part is positive, but another part is negative, right? All right. So, therefore, this is the reason we are going to look from both sides, approaches to 2 from negative side and approaching to 2 from the positive side. So, limit x approaches to 2 from negative side, let's say. We have, f of x minus f of 2, that's our point, f of 2, right? Any value of x, and this is a starting point, this is ending point, or starting point, ending point, it doesn't matter. Okay, x minus 2, right? Okay, so this is our x, this is 2, is equal limit x approaches to 2 from the negative side, and we have absolute value x minus 2, because f of x is absolute value x minus 2, minus 0 to x minus 2, and we are getting negative 1. Why negative 1? Because it approaches from a negative side, right? If it approaches from negative side, it's going to be limit x approaches to 2 from negative side, so it's going to be negative x minus 2, right? X minus 2. This is going, this is going to be gone, and I'm going to get limit as a negative 1. Derivative from the left. Okay? Now let's take derivative from the right. So limit x approaches to 2 from the positive side. We are getting f of x minus f of 2, x minus 2, this is equal limit absolute value x minus 2 minus 0, x minus 2, x approaches to 2 from the positive side, and here we are getting positive 1 by same reason. Instead of minus, I will have plus in front, right? will be positive 1. And as we can see, based on the principle of one side limit, if left side limit is not limit from the left side is not equal to limit from the right side, let me see, f of x does not equal limit f of x from the right side. Okay, therefore, the function is not differentiable. The function is not differentiable. Okay, and the graph of f does not have a tangent line at the point 2, 0. There is no tangent line at the point of 2, 0. To provide some similarity about with the polynomial, we can take x minus 2. It's also the binomial. It's a type of polynomial, right? Remember, polynomial cannot have a sharp corner. It's not a polynomial. So this is the result. It cannot have break also, right? Polynomial like this cannot have break. But the polynomial has to be smooth corner. Okay, smooth turn, but not the sharp one. And as you can see, the limit here is not also accepting from the point of slope, doesn't accept sharp turn also. Okay, moving to next question. So next and last question, number 4. Is the following. So we need to find equations of two tangent lines to the graph of f that passing through the indicated point. Okay, so what do we have? We have function f of x that is equal x squared plus 1. So we need to find the equation of two tangent lines that are crossing in the point -1 and -3. So let me show you on the graph. Okay. So our graph is going to be x squared plus 1. So not bad at all. I'm proud of myself. Well, okay. So this is x squared plus 1. And tangent lines are running into each other at the point of -1, -3. 1, 2, 3, -1. And this is going to be the point where they are going to cross. Okay, let me then draw the tangent lines. Something like that, right? And the other one, it's going to be like this. So it's touching here this point, here is touching this point. All right. So this is -1, -3. Okay, so let's find the equations of these two tangent lines that pass through the points -1, -3. All right, so since let me take some x0, y0, anywhere, it's not important. So I'm going to take x0 and y0 points as an end point, and that is going to be a point of tangency on the graph of f. And by the limit definition for the derivative, f prime of x, it's going to be equal to x, right? All right. So the slope of the line that goes through -1, -3 point and x0, y0, these are going to be our 2 points. One is given, one I'm taking arbitrary, any coordinate, can be any coordinate on this on this tangent line. Okay, so it's gonna be -3. So y2, I'm doing y2 minus y1, x2 minus x1. I'm finding the slope. So its slope is going to be -3 minus y0 and -1 minus x0. It's going to be 2 x0y, because the slope of the line through -1, -3 and x0, y0 equals to the derivative of f of x. It's right here, f prime of x, which is equal to x, but at the point of x0. Okay, from here I'm going to do some algebraic changes. -3 minus y0 is equal to x0 times -1 minus x0, and y0 I'm going to replace with x0 squared plus 1, meaning our original function in the point of x0, right? This. So at the point of x0, it's going to be x0 squared plus 1. So what do we have? -3 minus, let me change the color so you can know that I replaced y0, x0 squared plus 1. Okay, and this is equal to x0 times -1, and multiply might as well, opening up, and minus 2x0 squared. Okay, so from here we have -3 minus x0 squared minus 1 plus 2x0 plus 2x0 squared equal 1. So basically everything I move to the left so I can solve it, and we have x squared, x0 squared plus 2x0 minus 4, right? And this is equal 0. And if we solve this, we are going to get x0. I can break it down because I have -4 and 2. When the product is less than sum, that means you can't FOIL it, right? So I'm going to with the method of discriminant. So x0, to remind you real quick, when you have ax squared plus bx plus c is equal 0. So x12 is equal negative b plus minus square root b squared minus 4ac over 2a. Yes? Is it readable? I don't think so. Okay. For AC. Okay. So from here, x0, 1, 2 is equal negative 2 plus minus 4 plus 16, which is equal negative over 2. Negative 2 plus minus 2 square root 5 over 2. All right? So x0, 1, 2 is equal, I'm taking 2 out, negative 1 plus minus square root 5 over 2. So this 2 is gone. And my result is, I'm getting, let me write down this color, x0, 1 is equal negative 1 plus square root 5, and x02 is equal negative 1 minus square root 5. Okay, when we have plus, it's going to be negative 1. Negative 1 plus approximately 2.24. It's going to be 1.24. And x0, negative 1 minus 2.24, it's approximately going to be 3.24. Let me put here also sign of approximation. Okay, 3.24. So, therefore, the points of tangency are going to be following our original function, f of x is equal x squared plus 1. Hence, so we get 1.24 comma 2.54. This is 1 point of tangency, and the other one is negative 3.24 and 11.50. I just put 0 because everywhere I have two decimal notation, so just to keep the format. All right, and corresponding slopes are going to be for slopes. Okay, so here I write down points of tangency. And here we have slopes. So it's going to be f prime of x. It's we have 2x, right? And from here we have equal to x. So it's equal 2 times 1.24 which is times 1.24, which is equal 2.48. And for the other case, 8 prime x is equal 2 times negative 3.24, which is equal negative 6.48. And now let's write down equations, because we have already slope, right? And we can figure out our equation of tangent lines. So remember here we put down this, where is it? Ah, here it is, negative 3 minus y squared, negative 1 minus x squared equal 2x0, right? So I'm going to use this to write down, just like exactly in algebra, right? When you have slope and at the point, you figure out the equation of the line. Actually, next video, I'm going to put the algebra part of it. So if somebody doesn't know this stuff, they can use it. Okay, so let me rewrite. Negative 3 minus y. I'm not putting y0 as a specific point, but in general, any point. So minus 1 minus the x is equal to x. So since both numerator denominator is negative, I'm going to put negative in front of and the numerator and denominator, which is not going to change anything, right? Because it's still going to be the same sign, right? Okay, so this way I'm going to flip and I will get y plus 3, and here I will get x plus 1, and is equal to x. So from here, y plus 3 is equal to x and x plus 1. Okay, so this is formula for our equation. So I'm going to write down for the first one, for the slope, 2.48. So we will get y plus 3 is equal 2x is already 2.48, right? Yes, see, here we have multiplication already. We multiplied here, remember? Otherwise, I would put 2 times 1.24. So it's going to be 2.48 times x plus 1. And I'm going to get y is equal 2.48x plus 2.48 and minus 3. So from here, y is equal 2.48x minus 0.52. Next, for the slope of, let me write down here, slope is equal negative 6.48, right? So we have, let me see, negative 6.48. We have y plus 3 is equal negative 6.48 times x plus 1. So y is equal negative 6.48x minus 6.48 and minus 3. So from here, y is equal negative 6.48 minus 9.48. 6.48x. So what do we have? The equation is a equation of decreasing line, right? Negative 6.48 minus 9.48. Let's see. Let's go back to our graph. Here it is. So decreasing line, this is this one, right? Yes. And the other one is increasing, so slope has to be positive. Let me go check. I believe it was positive. Yeah, 2.48x minus 0.52. And we have those are our equations. So we found found the equations of the two tangent lines to the graph that passes through the point -1 and -3. Okay, I'm done. Thank you for watching. See you next time.